Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 111th of physics. As I told you in the previous lecture that we will discuss few work example based on the theoretical portion of previous lecture. So today we are going to discuss that first work example. Let us first understand and we will get the data as we are reading the work example. So please pay full attention. The work example is saying if 30 coulomb of electric charge flows past a point in a wire. So I have written because charge is represented by capital letter Q. So I wrote that 30 coulombs in 2 minutes. We need the standard unit as a second. So we have to convert these 2 minutes into seconds. For that we have to multiply 2 with 60 and as a result we will get 120 seconds. Now they are asking what is the current in the wire, and as I is the symbol for representing the current. Ladies and gentlemen, we know that Q is equal to IT. So if we are finding I, so we will get Q divided by T. Now both Q and T are given, so we are writing 30 instead of Q and 120 on this. So we will get 1 over 4 and that is equal to 0.25. So here we will say that I is equal to 0.25 ampere in the wire. Let's turn our focus to the second work example, and the second work example is saying that the current in a lamp is 0.2 ampere. So for you people I have written it here. I is equal to 0.2 ampere. If the lamp is switched on for 2 hours, here the unit is hours, we have to convert it to seconds. For that we have to multiply 2 with 3600. Why? Because there are 3600 seconds in 1 hour. So when we multiply 3600 by 2, we will get 7200 seconds, and I wrote that for you people in advance. Here, what is the total electric charge passing through the lamp? Now charge is represented by Q, so I have wrote it here. Now again I am writing that Q is equal to I and T. Simply we have to insert the values 7200 and I is 0.2, and as a result we will get 1440 coulomb, because the unit of coulomb in charge is coulomb in SI system. Okay, that was the practical usage of the Q is equal to IT, or I is equal to Q divided by T. Now let's turn our focus to another very important topic, and that is electric symbols. If you want to take physics as your future subject, then you have to understand all these symbols. In this course, we will use one of these symbols somewhere in the topics. So you have to understand the electrical symbols which are commonly used in the electric circuits. So for that, I given you that in the form of a table. In the first column, the electric symbol is used, and in the second column, the name is written. So whenever we are dealing this sort of symbol, then it means switch, but this switch is open. When you are connecting this line with this, so it means the switch is closed. Immediately after this topic in today's lecture, we will see the practical usage of this switch symbol, that what that is doing. Now the second symbol is a cell. There is a negative terminal and there is a positive terminal. So this is a cell which we are using very frequently in electric circuits. Now when we are using a battery that is called high tension battery, then there are many lines inside this. So it means that it is a battery. That is a dry cell. But this is a battery in which we are using acids, etc. Now this is a power supply. We will use this power supply very frequently when we are providing supply to different devices. Then we are using in the circuits in the form of a symbol as this one. Now if you are taking a joint, you are taking a junction from a wire to a bulb or to any electric device, then this symbol is used, because this is the main wire and this dot is showing that you are taking a joint from it. Okay, the next symbol is very interesting. This is a cross wire. Now this is not a junction. You are not taking any junction from this wire. If this is a wire, then this wire is only crossing above this line, but it is not a junction joint. You are not taking any joint from the wire as shown in this figure. Very technically, sometime we are using this as like this. If you are taking passing, so this symbol is used. It means that this is only a wire going above the other line, but there is no joint taken inside this symbol. So this is another symbol. Now for lamp, either this symbol of cross or this symbol is used, and we will see the practical demonstration of these symbols in a moment. Next is fixed resistors. There are two types of resistors. We will discuss that in greater detail in this course, but the symbols for fixed resistor is this one, and for variable resistors these symbols are used. You will see the practical usage of these symbols. Variable in rheostat, it is also written here rheostat. It is called rheostat. Now, fuse is a very commonly word used inside electric symbol. So these two symbols are used for fuses. Now, coil of wire is also of great importance in the construction of electric circuits. So this is used for coils. We will use all these symbols somewhere in this course, so be ready and understand it. It is a transformer symbol. One is step down transformer and one is step up transformer. We will discuss that in this course, but you have to understand the symbol for transformer here. Now the next symbol is galvanometer, and you know that galvanometer is used for detecting the current. Either in a small circle G is written to represent galvanometer, or there is an arrow symbol inside the small circle, and that is also representing galvanometer. Now, if we want to represent a meter in the circuit, then there will be an A inside a small circle, and that is representing ammeter. You know that ammeter is used for measurement of current. Now there is another very important symbol used inside electrical circuits, and that is voltmeter. This is used to measure the voltage or potential difference. There is another very important symbol, and that is two-way switch. When you are pressing the button, so sometimes this line is connected, again pressing upward will connect this. Sometimes it is performed automatically on the given situation, so we can use these two-way switch in relays, in electrical relays. What are that? Wait for that, we will discuss. You saw many times this symbol in the previous electrostatics, and that is earth connector. When you want to take the earth from a device, so this symbol is used. Now there is another very important symbol, and that is capacitor. Capacitor is a device for storing the charges. It is very technically also known as condenser. So capacitors can be connected in parallel or in series depending on the situation. So wait for that. When there is a symbol of equal length of two parallel lines, then this is capacitor. But if one line is smaller and the other is larger, then it is used for cell. Keep this in mind. Now let us use the above symbol in a practical situation, how to demonstrate a practical circuit on a piece of paper. Whenever you are designing a practical circuit, first you have to plan that on a piece of paper, and then you have to use those symbols keeping in mind practically. For example, if you are designing a circuit for a building, that from where the power supply will come and how the lines will be distributed to different rooms and to different devices, then you have to first do all these activities on a piece of paper. That is called the electric circuits on a piece of paper. So in those diagrams we will utilize these symbol. So let's see how we can represent some circuit diagrams using electrical symbol. Now you learn that there is an ammeter. So these symbols are showing you the ammeters, and they are registering the reading of current. They are showing you the measurement. Now as I told you that there are two type of switches, one is closed and one is the open. When the switch is open, it means that no current is passing through that circuit and the devices are disconnected. As you are pressing the switch in your rooms when you are entering, so it means that you are closing the circuits, and as a result the current is flowing through that circuit, and we are seeing the outcome of that. If we want to turn on a light bulb, then the light bulb will be turned on, and if we are switching it off, then we have to disconnect the circuit. One very important terminology I have to tell you, and that is we are using very frequently in electricity. We are saying that the circuit is now complete. So it means when you turn this switch close, then it means the circuit is complete, and when the circuit is completed, current will flow through that circuit and you will see the results of that. Now in this particular case, if the circuit is open, light bulb is off. This is the symbol for light bulb, and we are calling this very technically as an open circuit. When the circuit is closed, then we are seeing that this circuit is closed, and you can see the light bulb is on here because we close this switch. This is a symbol you learn used for the cell, which is providing the necessary electrical energy to turn this bulb on. How much energy this cells is producing in the form of current, then ampere ammeter is used for the purpose to understand this current flow, that how much current is passing through this circuit at this particular moment. So one is the closed circuit and one is the open circuit. Open circuit means that there is no current flowing. Closed circuit means that current is now flowing inside that circuit. There are two other very important terminologies used inside the physics, uh, and they are the open circuit and short circuit. Open and short circuit. We are discussing that here in this particular diagram, which is above, which is below the final diagram of this. Now, what is the open circuit and the short circuit? Open circuit is the example shown in this diagram. This diagram is open circuit. An open circuit occurs when there is a break in the circuit to stop the current flow from flowing. The current from flowing. The break in the circuit can be due to a loose lamp holder or a missing wire in the circuit. So it means that there is a missing wire or the lamp is loosely fitted inside the circuit. So that is called the open circuit. The second type of circuit, and that is the short circuit, is shown in these two diagrams. These are the two types of short circuit. If you want to bypass a certain device inside the diagram, then you have to take a wire just like here shown in the case of wire A. So when the current is flowing, it will flow in this way by passing this cell. So cell will not play any role inside this circuit, and directly the circuit the current will flow to the bulb. Because there is no power from the battery, so the light bulb is off, and we are calling this as a short circuit. We are calling it as a short circuit, and these two are the example of short circuit. The wire A acts as a bypass for the current flowing out of the positive terminal of the cell and into the negative terminal without flowing to the rest of the circuit. So you can see that it is taken from the positive and it is going to the negative part, which is this one. The positive terminal is this one and the negative terminal is this one. Now it is easier for the current to flow through wire A than the rest of the circuit. Now here in the second example, there is a variable resistor and current is passing through in this way. This is a power supply, and when the switch is turned on, the power supply is turned on. But we don't want this bulb to be turned on, so we are bypassing it, and the current will go in this way. So this bulb is written here, light bulb off, as current bypass it by flowing through the wire B. So this is a wire B and the current is easily going through. It is not going in this direction. It is going in this direction and it can pass easily through these wire B, which is used as a bypass for the bulb. And as a result, the bulb will not be turned on. So these two figures shows another example of a short circuit. So there are closed circuit and open circuit, and there is another terms which is used very frequently, and that is a short circuit. Short circuit means that if we are bypassing a device inside a circle, then we are using the terminology of short circuit here. Tomorrow we will discuss another very important term, and that is of extreme importance in my mind, and that is electromotive force, which is simply known as EMF, and also we will use potential difference. What is the difference between EMF and potential difference is of extreme importance as far as electricity is concerned. So be ready for tomorrow's lecture. Don't go anywhere because we are going to discuss a very important topic in that video. Thank you very much for your time. Allah Hafiz.